My name is Charles Lowe, and I am the Chief Executive of something called Digital Health and Care Alliance. The Digital Health and Care Alliance is a group of about 1,000 members who are interested in digital health, specifically interested in selling or working with the NHS. We do actually have a few NHS members as well. We've been going now for 10 years, so this is our 10th anniversary, we charge nothing for membership. We produce a newsletter about every 10 days, which has new digital health related things in it. And in fact, this presentation I'm going to give you now was drawn largely from previous newsletters. I did a search for things like COVID-19 and infection control, things like that, and pulled these up. So you're welcome to join. It will cost you nothing, but you will get 3 newsletters per month if you ask for them. So the menu for today. I'm going to talk about the basics of what digital health can do. I'm then going to look at something called contactless early indications. So I'm sure many of you will have been to airports, for example, in the last 2 or 3 years, and whether or not you were aware of it, there was something that was actually checking on your body temperature, maybe also checking on your heart rate and your respiration rate, and drawing some conclusions from that, and occasionally taking people to one side to check them. Then something on building air. I found a long time ago a device for detecting COVID-19 in the air, and I've been wandering around the exhibition this morning talking to a number of people, so I'll draw out 1 or 2 things there. The issue of contact tracing, which the previous speaker spoke about, I've got a slightly different aspect of a way of looking at that. Then the issue of behavior change, which I think is very important, because the thing about pandemics is that they make people behave differently to usual, and they're required to behave differently to usual. And digital can actually help with overcoming some of those issues that creates. Now I've got digital diagnosis, a little bit of the technology of working in the hospital, treatment, and then I'm going to spend quite a lot of time at the end talking about a dashboard, because I was very privileged to be working with a company that produced a dashboard for the whole of the United States. We did try to interest the task force in the UK, the COVID-19 task force. I'm told they had some other dashboard which I've never seen, but I was fortunate to see the American dashboard, and indeed it has been published, so you can see more about it if you want. A final point I'd make about this presentation is that there are so many different strands that one can go down, so you could talk for 3 hours about this. So what I've done is, if you want to write to me afterwards and ask for a copy of the presentation, I've got all of the notes which have a number of links to things on each page, so that might be of some help to you. So my principal messages are that I was asked to talk about infection control in general, the digital approach to infection control in general, but I'm drawing obviously heavily on COVID-19 experiences. My main view is that digital technology enables a much faster and a more coordinated action. And that because most people now have smartphones, they're an extremely effective enabler of that digital technology. The downside of all this, though, is that the technology always creates inequalities, and this is a continuing concern. Thankfully, most people have smartphones now, but not everybody does. Something else that has started to emerge recently is our privacy concerns too, which actually limit some of the things you can do. The overall message from this is that there are few narrative threads. When I give a presentation, I like to have a narrative thread that runs right the way through it. And you can sort of say that COVID-19 is that thread. But you'll see it's extremely bitty. So the basic contactless digital health functions, you're looking at simple sensing and things like temperature, respiration rate, heart rate, and stability. Stability is particularly important for older people, and particularly important for people who may fall. So you can actually predict if there is a problem. But I thought I'd include it in here. It's worth pointing out that even normal body temperature varies by up and down about 1 degree centigrade. So one needs to be slightly careful about drawing conclusions. You measure temperature typically through a sensitive infrared device. Respiration rate you can measure by the ever so subtle changes in the color of people's skin as they breathe in and breathe out. You can also use radar to do it. There are a lot of very sophisticated radar systems now that will do that. And I remember many years ago when I was running the telecare system in the London Borough of Newham, we were taken over to the Philips setup in the Netherlands, and we've shown a radar system that they had which enabled them to detect 24 people at any one time and measure their heart rate and their respiration rate simply from the way radar bounced off them, which is very, very impressive indeed. Unfortunately, blood pressure still requires a cuff to be accurate. And I just mentioned this plethysmography, which you can do with radar, and that's basically measuring closed spaces in somebody's body. So you can measure how quickly their lungs are expanding and contracting. One of the stands when I went round that particularly struck me was the Baxter stand, which had some Welsh Allen devices that were really good for basic contactless digital health functions. So, early indications. I think most people know of the story of the Google flu trends. Google came up with this idea a long time ago that if people started searching for flu, there was a pretty good chance that there was flu around. That took off at an early stage, and then suddenly someone realized that there was some potential privacy issues. So Google stopped publishing the information in 2008. They still collect it, and if you go on the Google Flu site, you will see that if you can convince them that you're a pro bono medic and you're not going to use it in any naughty ways or what have you, you can still access that information now. There are also, of course, regular polls. I have something called Flu Survey, which I've shown as a picture there. And Zoe also, during COVID-19, did regular checks on members of their organization. I recently came across something called Blue Dot, which takes this to a completely different level. And it's basically a massive review of all online media, looking for references to COVID-19 or flu or what have you. And it also includes airline ticketing. So not only can it actually detect the emergence of a problem in one or other part of the world, but it can actually tell you where that problem is most likely to appear next. So very impressive indeed. Some of you may be aware that, that over-the-counter medication purchasing changes are monitored carefully too, as an indication of issues. And one of the points about AI, which I'll be drawing out throughout the presentation, is that it's very good at picking out the signal from the noise. So it enables you to do these things. And just for completeness, I would add that there are so many other ways in which you've done, including sewage analysis. So, moving on to the air we breathe. This is actually a system made by Smith's Instruments, and it claims to be able to detect COVID-19 in the air immediately. Well, presumably with a short lag anyway. And there are, when I was walking around the exhibition this morning, there seemed to be quite a lot of other ones that were mentioned. Air DDS, for example, reckons they can do same-day identification of anything in the air. There are a number of cleaners as well. There seems to be a slight debate about whether UVC needs to be screened or not. Between UV Medico and I need to put my glasses on, I can't see it, what I've written, and Midtherm. TPA filters air. Radical has a hydroxyl generator that apparently scrubs the air, and it also scrubs surfaces too. And finally, Hygieno measures surface contamination. So there's lots of stuff up in the exhibition for you to look at there. And I guess it's worth pointing out, one of the things I do as well is review proposals to the government for government funding. And one of the things I've picked up occasionally is systems that monitor the air to tell whether or not a mold is growing in some part of a building and take the necessary action to prevent that mold from being there. So, moving on. Contact tracing. COVID-19 tracing reached its zenith in China. It was there was centralized and localized contact tracing. There were the COVID-19 contact tracing in the UK is now going to be discontinued in a couple of days' time, I'm told. And if you go on the NHS website, you'll see that they claim significant benefits from it. That in the first year it prevented 1 million cases and 44,000 hospitalizations and 9,600 deaths. I think the really important point about it is that it's a way of slowing things down so that you can get a cure or some form of prevention going elsewhere. I don't think anyone would, for something as fast-moving as COVID-19, no one would claim it to be a perfect solution. I would particularly draw out something called EpiRisk, which is a population flow monitoring system, which is really hugely impressive, that I came across recently. So, moving on to behavior change. The thing about pandemics is that things change to other emergencies. So individual actions can significantly worsen outcomes in a pandemic. There can be fear of infecting others that makes infectious diseases more insidious through disease-related stigma. Physical gatherings, typically used in other circumstances, are extremely bad news for this. But thankfully, chatbots can overcome much of that. And the United States chatbot version was something called Clara. But what you've got showing there is the World Health Organization's version, which can speak 7 different languages and is extremely good at telling people what the right information about COVID is. It was diverted from the healthy lifestyle and mental health advice specifically given to fight COVID. So moving on to digital diagnosis, there is a physical way of diagnosing pandemics, and that is via things called wearables, which continuously measure your temperature and your pulse rate and your breathing rate and 1 or 2 other things. And by doing that continuously, they can give you a very early indication of when there are problems. And in fact, they can give you such an early indication that they can tell you before you actually know that there's anything wrong with you. Then there's a methodology called loop-mediated isothermal amplification, otherwise known as LAMP, which is one of the cheapest and easiest ways of actually detecting viruses in large populations. There is increasing availability of point-of-care testing too for other diseases. For example, now you can get through the post a UTI check that will check your urine. You use the smartphone camera to read the QR codes, and you're away. The standard remote patient monitoring, of course, measures blood pressure, breathing, weight, SpO2, and such like. So lots of different ways in which you can use digital to diagnose. One thing I did want to draw your attention to, I would just mention under that digital diagnosis that Abbott has a most impressive piece of equipment upstairs that can detect COVID-19, flu, strep A, and RSV in between 6 and 12 minutes. Finally, I wanted to draw your attention to something called Res App, which has recently been bought out by one of the majors. And it was originally an SME that was monitoring COPD and asthma, and they managed to pivot their app so that it could pick up COVID, and it detects 92% of positive COVID cases with 80% specificity, which is hugely impressive, and obviously made a lot of money too for the people who built it. So, looking at the hospital, you can use neural networks there, and they've been used to predict COVID-19 outcomes for admissions. Measured by the area under the receiver operating curve, otherwise known as the OROC, the prediction of hospital mortality from people who came into the hospital in the first place was 93%. For mechanical ventilation, 92.5%, and for prolonged stay, 86.5%. Very, very impressive figures. And it dramatically improved the screening for COVID-19 on admission, say, into accident and emergency. So looking at the treatment side now, digital proved to be essential in running the geographically spread trials of vaccines and drug effectiveness against COVID-19, and we could spend half an hour talking just about that. There was also a key aspect of driving respirators and sensors and things like that. And just an aside, because I'm a bit of an exercise nut, I've added there, it's nothing really to do with digital, but it just intrigued me, that exercise apparently proved to be a good way of minimizing the impact of COVID-19, and singing proved to be a particularly good way of recovering from long COVID, apparently. So I'm going to move now on to the COVID dashboard that I was mentioning earlier, which to me is really very important indeed, and something I should be drawing out. It was the particular thing I'm talking about now is something called Project Salus, and Salus was apparently a Roman savior. And this is an icon taken from St. Peter's Basilica in Rome. It was built by a company called Humetrix that I have done a little bit of work with. And what they did was they used Medicare data. If any of you have looked at how things work in the United States, they're not allowed to give out a single NHS number equivalent. So it was impossible for anybody to work out everything that was happening in the United States. However, Medicare information is available for the whole country. So what Humetrix did was they used the raw data of things like infections, hospitalizations, deaths, and medications, etc., and built this fantastic geographic model of what was happening, which turned out to be a pretty good indication of what was happening right the way across the system. It was able to predict hospital occupancy and infection rate, and most importantly, to direct people to areas where there were going to be major outbreaks. And so this is what it looks like. Of necessity, it is very, very concatenated, so I don't expect you to be able to look at it in great detail. But just to give you some idea as to what you're looking at there, the statistics shown on the right-hand side are for US Medicare population. So it's not the whole of the US population, but just of the US. The graph on the right there was Medicare infections versus total infections. The cases on the left-hand side were again for the top county in the United States that had the worst cases, and underneath there were the hospitalizations and the deaths for that particular county, and then subsequently also there were some other statistics underneath there too. So zooming in to Los Angeles, what you've got here is the individual counties. The darker the individual county, the greater the number of hospitalizations, and the circle diameter is the number of infections in each of those counties. So it just gives you some idea as to what's happening. There we go. And then finally, on the left-hand side, the second page there has the ICU count and ventilator cases, if you're interested in them. To me, this is an interesting graph because this is Medicare as a total percent of all cases in America. And as you'll see, originally, older people were a very, very high proportion, and it dropped down to 20% as time went by. So moving on, if you remember the previous picture that was shown, you can see that now there are actually very few reported infections, and this is further on from the previous graph. So it gives you some idea as to how infection rates are changing across the United States. And here you've got cumulative infections, and what they did was they did a regression analysis, and the regression analysis enabled them to work out where the greatest risk of infection was in the future, and where the problems were going to be. And the darker the county, the more serious the issue. And this was used in the United States very effectively for distribution of therapeutics and medicine and vaccines, and very much for PR focus. Finally, just to demonstrate, you can actually drill down right to an individual to individual medical centres, as has been done here. So you can see the load on individual centres. This is in Kings County in New York. So, as I say, it's a really very impressive system. Doubtless, if we get another pandemic, that will be further developed. So, just winding up now, as far as I'm concerned, the biggest legacy from COVID will be encouraging the greater use of technology to change the way that healthcare is delivered. And I maintain that will change forever, and doubtless one or two of you will want to have a dispute with me afterwards, but I think it's very much for the good. In view of the time, I'm just going to limit that by mentioning one or two things on that list there that Daniel Kraft came up with. One is the move from sick care to healthcare, how you can use the technology to help people stay fit. And the change from episodic to continuous, which again improves the level of care very significantly. Physical to virtual, which was originally a necessity, but now enables much better throughput. And then finally, the one-size-fits-all to personalize. As everyone points out from time to time, our DNA is, everybody's DNA is within 1% of everybody else's DNA, but only 25% apparently of your stomach biome is actually shared with other people. So you have very personal impacts with medication. And the key drivers here, as far as I'm concerned, are professional acceptance, patient acceptance, particularly patient acceptance, that they are responsible for their own health, cooperation and data sharing, and adequate funding. And tech can help this by offering continuous connection, continuous analysis, and by developing ML and AI. So that is the end of my presentation. Thank you very much indeed.